Welcome to the lecture series on soft computing in computer science. This session we are going to see about intelligent optimization algorithms part 4. Particularly we are going to cover two algorithms. One is artificial bee colony algorithm, another one is ant colony optimization algorithm. Finally, this session is going to conclude with various nature inspired algorithms that act intelligently towards the goal as well as the application of optimizations in the real world engineering sectors. So, I wish to recall the previous sessions that dealt with intelligent optimization algorithms. Two sessions we have talked about genetic algorithm. So, it is a kind of intelligent optimization algorithm that draws its inspiration from Darwin's evolutionary theory, and this is another optimization algorithm that branches a new avatar when compared with the evolutionary approaches, and it is collectively called by the name Swayam Intelligence. And here in this session we are going to deal with the two algorithms. One is artificially bee colony algorithm, another one is ant colony optimization algorithm, and these two algorithms again falls under the category of Swayam Intelligence. So, this is one category comes under evolutionary algorithms, and these three are another set of algorithms comes under Swayam Intelligence. But collectively this evolutionary algorithms plus the Swayam Intelligence algorithms are collectively said that bio-inspired, because it is bio-inspired optimization algorithms or nature-inspired optimization algorithms. So, in many names it can be called, but the original idea is how the nature or how the biology is working and how to draw inspiration from the biological process or the natural process to go about with solving optimization problems. So, that is what the general theme, right. Let me discuss about ABC first, then ACO. What is artificial bee colony? So, first of all, it is an algorithm for solving an optimization problem. It has been proposed by Dervis Garboha in the year 25. It is inspired by the foraging and the information sharing behavior of bee. Again it is foraging behavior. Normally if you look at the literature, why these much nature inspired or bio inspired algorithms are available, and what is the motivation is, or what is their principal inspiration is, there are two behaviors. One is foraging, another one is shelter, third one is mating. Based on the three behaviors you can categorize all these algorithms. How a living organisms search for its food, there is an optimization behind that searching process. How the living organism is preparing its nest, that is shelter, so there is an optimization behind that. How a living organism is finding its life partner to reproduce much more intelligent, much more individuals of their generations. So, there is an optimization behind that. So, all these three behaviors have been taken up while observing the nature or while observing the biology, and has been mathematically modeled, and it is mathematically modeled to create an algorithm, and that algorithm is very much useful for solving an optimization problem, right. So, this artificial bee colony algorithm draws its inspiration from artificial bees foraging behavior, how these artificial bees are collecting honey from the flower and how the hive is constructed, right, and during that honey collecting process some information is shared, where more number of honey is available, in which direction all other bees should go. In that way the optimization algorithm is designed, right. So, the foraging behavior. So, with respect to the foraging nature of bee, we may treat the entire bee groups into three different bee. Apart from the queen bee and other stuff, we may group the bee, those are meant for collecting the honey from the flower, that is the foraging, right. So, we may treat that as three kinds of bee: employed bee, unemployed bee, onlooker bee. So what is employed bee's duty? It stays on food source and provide the neighborhood of the source in its memory. It always stays on the food source. Food source means here flower or where it can find the honey, and provide its neighborhoods about the source, its memory information. Here is the place you can find a lot of honey, you can find more number of flowers, acres and hectares of land is there where a lot of flowers are there, you can go and collect more number of honeys, like this kind of information is shared, right. What is unemployed bee role? In unemployed bee you have two things, one is scout key bee and another one is onlooker. The scout bee is responsible, see the scout bee won't listen to the employed bee information, right, and going towards the direction of the employed bee. It will randomly go on its own style and tries to find out a new food position. In case if the new food position found out by the scout bee is more than the food position found by the employed bee, then all the employed bee will come to this towards the scout bee direction. And another one is onlooker bee. This onlooker bee sits in the hive, always it sits in the hive and look for the, that is why it is onlooker, it will look for the employed bee. That means employed bee informations. So there is some kind of information sharing is there between the employed bee and the onlooker bee, and based on the information the onlooker bee will go to the place where the employed bee is employed to collect the honey. So that is the three different categories of bee and their duties while collecting the honey for the nectar. Let me animate the foraging behavior of the process. So assume this is a hive area, this is a hive area. So in that hive area there are some space is allotted to know how the information sharing is happened. So this dancing is meant for information sharing, how the information sharing is made, right. Now assume that there are some gardens are there, this one flower represents one garden, say for example garden 1, and this another flower refers to garden 2, this refers to garden 3, and this refers to garden 4. There are 4 gardens are there covering this hive. Now bees from the hive are flying towards the garden to collect the honey. So what bee it is? It is employed bee. Now the employed bee from the hive is flying and trying to collect the honey from the flower. So one set of employed bee go to the garden 2, another set of employed bee go to the garden 4. Now it is getting into the garden and collected the honey. After getting into the garden and collected the honey, then only it knows how much of food quantity it can collect, and based on the information sharing the bee can communicate among themselves which garden is having more number of honey. So after collecting the honey, these bees are come to the position. So since this bee is not finding enough honey in garden 4, it come to G3, that means garden 3. Whereas this honey bee that is entered into garden 2 has find more amount of honey, and that it comes to hive. Why it comes to hive? To tell other onlooker bees. Now see the scout bee is random. Even though the employed bee comes, it won't listen to the employed bee information, it flies random to its preferred location, right, and starts getting the honey. Now the onlooker bee, now the employed bee from the garden 2 is also comes. So this onlooker employed bee go to this garden 1 first and then garden 3 first. This bee goes to this garden first. Now onlooker bee comes out from the hive. Onlooker, this is onlooker 1, onlooker 2, onlooker 3, onlooker 4 comes out from the hive, and there is a kind of wobbling is there, right. That employed bee is doing some kind of wobbling and it is treated as dancing. So while dancing, what is has been happened? Some kind of information sharing is happened. According to that, see some more bee has come to this garden and some more bee are going to this garden, right. So it prefers which garden to go so that they can collect maximum amount of food in a lesser time. So what is the flow chart? After understanding the natural process of how the honey is collected by the employed bee, or how the foraging behavior is performed by the honeybees in the honeybee hive. We are tracking that process, and that process is inspired into an optimization algorithm in order to code using the any programming languages. We derive that process as a flowchart. So, to start the process, initialize the control parameters. Of course, we are not know what are the control parameters that are needed. Let me see those control parameters in the subsequent slides, and then the random generation of food source positions of employed B, and evaluate the food source. Where remember, in PSO it is particle position, whereas here it is food source position. Evaluate the fitness of the food source position. Apply the food source position by a local search, because some bee go to garden 2, some bee go to garden 4, some bee go to garden 2. So, there is a greedy selection which employed bee finds the best food source positions. So, those has been updated, and then calculate the probability for each food source position value. So, this probability calculation is exactly similar to the Rowlett wheel selection in terms of genetic algorithm. So, the then the employed bee comes to the onlooker bee. Now, the onlooker bee will look into the information shared by the employed bee through dancing, and then it goes to the food position. Now, the set of bees onlooker bee go to one garden and another set of bee go to the another garden. The evaluation of the fitness has happened, and based on the greedy selection, now the food source has been replaced. If the food source is not that much better, it has been abandoned and the new food source has been known. This process is repeated by checking the termination condition. If the termination condition reaches, that means yes, then it is stopped by giving out the global best value, otherwise it will again assign the food source position. The process is going on. So, this is the way in which you can implement the artificial bee colony algorithm. Let me illustrate these algorithms step by step by an example. So, what was the first step? Assign some control parameters. What is the second step? Initialize the solution. What are all the process that has to be repeated? Employed bee and the calculation of bitness, onlooker bee and calculation of bitness, scout bee and memorization of best bees. These are the 4 steps that you should be repeatedly calculated, and finally if it reaches the optimal solution and there is no more improvement, you have to stop the process. First one, food source initialization. So, initial solutions. So, the number of solutions is equal to number. See how much number of solutions you want. That means this number of solutions is nothing but number of populations, number of particles, number of populations in general with the GS, PSO, or you can say number of particles with respect to PSO. Here number of solutions, right. So, now the number of solutions we have to randomly initialize the food position. The random initialization of food position follows this equations, that is within the range the food source position has been generated. How many number of food source? N number of food source. The N may be 10 or 20 or 30. What is J? How many values that has been produced. So, accordingly the initial solution has been generated. So, send to each solutions. So, the number of solution is equal to employed B. Then calculate. See, say for example, if I want now 5, then the employed B is 5. 1, 2, 3, 4, 5. Now, what is the fitness? It means each bee is going to the corresponding garden, maybe garden 1 or garden 2, garden 5 or 5 different gardens, and it's find its fitness value. So, fitness values are f of x1, f of x2, f of x3, f of x4. So, for each employed bee, that means for each solutions that we have randomly generated, we have to evaluate the fitness value. Now, this fitness value has been passed on to the neighboring hood, because the neighborhood also should know, right. So, the evolve the solution process is carried out by Vij equal to Xij, that is the formula that is. This is the evolved solutions. So, what is pi ij? It is a random number. What is the I? It is the each food solution, maximum number of food source, the dimensions and the random number generation. So, this is the best fitness value. Now, the each individual solutions has been compared with the evolved solutions, X and V are solutions, the best is taken. Finally, the best solution has been taken. This is the employed bee phase. Onlooker phase. What is onlooker phase? The employed bee comes to the hive, do some dancing, and the food position is been taken. So, for this to be happen, we are calculating the probability for each solution, then select the solution due to probability. So, employed B, onlooker B, right. So, the employed B will having the some set of values and the onlooker value have some locations, right. So, one random value is generated onlooker B, and another set of B's we are calculating it to know the onlooker phase, right. See the employed B 1 and 3, 2 and 2, 5 and 3, 4 and 4, see accordingly the fitness values have been shared among the individuals. So, evolve solution to the neighborhood, select the best, see same as the employed fee phase, select the better solutions like employed fee phase, what is that onlooker phase, and here you can find employed fee phase, the same thing is here. Okay. This one is compared with 3, 2, what is that? 1 is compared with 4, 5, see employed fee. This is a kind of dancing area. So, where that dancing is performed. So, 1 is compared with 1. Suppose in case other things are then it will, the onlooker will go to the place where it finds the more number of positions. So, this is the dancing position. And send scout. So, scout B after this onlooker phase with respect to the employer fee phase, like what has been illustrated previously, how to select the best foot position. Here the scout B is doing its own push position. So, here number of times it has been randomly chosen has been limited, maybe over the period of span the scout phase may be 1 or 2 times or 3 or 4 times, but within very limited time. So, the scout always tries to be sent to a unexplored position. So, it means that you have to generate a new random number, that random number need not be the random number that has been already in place. According to that you have to generate a random number, but it has been certain with the limit. So, this is the scout phase. So, these are all the 3 phases by means of which you can understand the artificial bee colony algorithm. So, what are the control parameters? The swarm size, you have to mention how this is the population size, how much employed bee, and in a swarm you have to generate 50 percentage, say for example if you mention swarm size as 30, then 15 employed bee should be there and 15 onlooker bee there and 1 scout bee there, like that. So, then these 2 parameters are already the common parameter, limit and time. These are the control parameters. So, what is the exact difference? Say for example this sphere test function, let us take an example for case study. So, for this the dimension is 2, because suppose if I take this n equal to 2, so then it is x1 square plus x2 square. So, this is the idea. So, dimension is 2, the colony size I have taken as colony size or swarm size is taken, number of iteration 2, 200 trials of experiment. So, dimensions so now what is the limit? The limit is been calculated. So, you cannot define everything on your own, there is a formula for identification of the limit also, and it is a thumb rule where majority of the researchers have followed. Employed B colony size divided by 2, like this the remaining onlooker B also. So, the range for this is 0 to 3, 0 to 3. So, we have to find the value for the f of x. So, what is the employed fee phase? See random generation of the employed B food source position, and this initial, see this employed fee phase is subject to the objective function, see x1 square x2 square. So, x1 is 0.39, x2 is 0.27. So, if you substitute 0.39 square plus 0.27 square, it is 0.225. So, the fitness is 0.81. So, likewise you have to calculate for all the other B's, and if you find that 0.81 is the maximum value. So, the random initialization of population has calculated the initial fitness, and in that initial fitness the maximum fitness is 0.81. Now, this initial employed fee is doing the neighborhood search among this neighborhood. See, it has been changed to this one, this has been changed to this one, this is called neighborhood search. So, the search within the employed fee. And a new kind of combination has been found out, and a new kind of value has been found out. See 2.08, originally this 2.08 is B, and this 2.08 combination will made as a new employed fee neighborhood search, and if you could find that this 0.46 has been found out as a new employed B, see here. So with the help of this 0.208, that means by means of neighborhood search, that has been taken and this formula is applied. See, j equal to 1, j equal to 2, k equal to 4, xij 0.27 and 2 xkj, that is the random selection of the initial for which the Vij has been taken. So this value has been updated. Now the new value is 0.392 0.1. Now if we apply this thing by means of greedy selection, now the fitness value is again improved. See, initial fitness value is 0.81 and the colony is this thing 0.39 0.27 and the updated new fitness value is now the overall fitness value is taken. So wherever some greedy is there, so we have taken that. So the greedy between old new phase and this. So this resultant colony is this. This is the now this resultant colony will be transferred to onlooker B. Or after comparing the every elements, each and every this and compared and this compared and this compared. So the blue or tick one which is having the maximum one and the red or one which is having the minimum one, right. See, since 0.32 is lesser than 0.5, this value is not updated, but this value is getting updated. So this is the idea. So this is the general principle of greedy selection, comparing its initial fitness value with the new fitness value. Accordingly the action has been taken and based on that action that value has been assigned for the new colony. So now the probability is calculated. Why the probability calculated and what is the inspiration of this probability? The probability is the one which is mentioning about the dancing phase, right. So based on the dancing phase, if we look at it, see this 0.81, see this a bit, the probability is calculated. 0.81 has 0.48 chance, 0.13 chance, see these are the probability. How these probability is calculated? This probability is calculated. The individual value 0.81 divided by summation of all these values. This is the probability. So how when a vector of value is given to you, how the probability is calculated for each value, that particular value divided by the summation of all other values. It is the 0.5. Likewise for all the values it has been calculated. This is a probability. So it means that 0.48 which is giving the fitness value, it has the more chance. So you have to give more chance to this individual. So in the onlooker B, that is having more chances. So accordingly the values has been generated in the onlooker phase. Now based on again the neighborhood search, you have to calculate the new onlooker B. So this is new onlooker B, this is old onlooker B. Some values, which value has been random chosen? Yeah, yes, this 1.81 has been random chosen for updating this value. So what is the value we got? Minus 0.63 we got. So it has been replaced with 0. Since we do not increase the negative value, if it is a negative value, it has been replaced with 0. This is onlooker phase. Now based on the onlooker phase, see here so that it will reset the lower bound value. Now in the onlooker phase we have two things, new looker B and new fitness, new onlooker and new fitness. So given the objective function, now the objective function has been increased to 0.93. So this is how the calculation has been carried out with respect to the given objective function 0.27, 0.93. Now we have two fitness value for the onlooker phase, new initial fitness, new fitness. After comparing the new fitness value, see 0.81, 0.93, which is greater, 0.93 is greater. So 0.93 individual has been taken as a new colony. Next one 0.22 and 0.25, which is greater, 0.25 is greater. So 0.25 fitness value is taken here, which is greater 0.9. Likewise we have to go for all the other cases, right. So up to this the onlooker phase is over. Now randomly you are generating these two numbers under the scout B, and for this scout B you are generating the, see how the scout B is generated, see 0.96 and 0.36, see randomly you are generating this, and for this scout B phase we are generating the index. So the limit is 10. So based on that the index value, the scout B value is updated. So if you keep on doing this process, your see this is has been generated with the 2000 iteration, and if you find that again there is a increase and there is a small increase, and overall there is no increase, both the best and the average values are increased. So what I am trying to convey to you is there are two different phases. One is random initialization of the population, that is the first one. Second, employed fee phase and greedy selection within the employed phase, and again the third one is onlooker phase and greedy selection in the onlooker phase, So that is all about the two phases, and two phases plays a major role, and the final phase is scout B phase. So if you call out these calculations, you can clearly very well understood that the flowchart of the algorithm. So what is this flowchart of this algorithm is telling? you have to start with the problem and you have to initialize the fee. See, you have to start the process and you have to initialize the control parameters. So, random initialization of the foot post position, evaluate the fit base. Now, update the foot post positions by local search. This is very important. So, now you have initial foot position, initial employed B and the updated employed B. Now, for this both the B you are calculating the fitness and by means of greedy selection you have to select. Like with the same thing, original foot position and the updated foot position. For means of greedy selection you have to collect the fitness value. So, these things is repeated iteratively until there. So, in between that you have to go for the scout phase. So, this is not the way in which you have to implement the scout fee phase in order to produce the better results for the employed B as well as the onlooker B, in order to clearly understand the idea behind the onlooker phase. And if you want to understand the convergence, so convergence is also the same, how the values are adjusted, how the generations are iterated and how the best fitness values are calculated. So, this is for all about the ABC algorithm, right. Next, ant colony optimization. So, what is ant colony optimization? It is an algorithm for solving combinatorial optimization problem and it is proposed by Margot Dorigo in the year 1992 and it also discusses about the foraging behavior of ants. So, this algorithm is meant for solving the combinatorial optimization problem effectively and it is proposed by Margot Dorigo in the year 1992 and it inspired from the foraging behavior of ants. What is combinatorial optimization? It is a kind of optimization that involves only the combination or arrangement of numbers 1 2 3 1 1 1 2 2 3 1 2 5 5 6, like this combination of numbers. Moreover, this combination numbers should be in discrete space. What are the examples or what are the applications? See, traveling salesman problem, minimum spanning tree, knapsack problem, 8 cues puzzle, assignment problem, vehicle routing problem. See, these are all the problems that comes under the category of combinatorial optimization. So, ant colony optimization is a kind of optimization algorithm that draws its inspiration from the foraging behavior of ants and it is based on the behavior of this algorithm. What is ants in nature? See, if you could see that in nature, if there is a food particle, here you have one food particle, here one food particle, see, ants are going random to get the food from the food particle. But over the period of time, see, random will think on its own where to go. If there is a food tree, see, this is food position G, this is food position J, let us take this is food position K. Now, ant here in this position, you forget about this, and in this position can try to see whether it goes this or whether it goes this or whether it goes this, right. So, over the period of time, if we could see that, see, initially there see, this is the food source position, this is the nest, initially the ants path are random in nature, but over the, see, this direction one ant, this direction is one ant, this direction is one ant, like that, so many directions. But over the period of time, see that there is a single line of path. How this single line of path has been established. So, this is the idea that Margot Dorigo has found out in the year 1992. So, based on that, for implementation we have given the flow chart. See, you have to start the process, initialization the control parameter. The most important pheromone is parameter is pheromone. Why the ant over the period is following the same path? Because ant, well, while it walking towards the food position, it displays some chemical substance. That chemical substance is pheromone. The other ants that is following the the path will smell that pheromone substance and then follow the same path. So, if you could see that the ants that is following the most path will have the more number of pheromone than the other path. It means that more number of ants are walking in that path, that is why more number of pheromones are deposited. So, that is the idea. So, you have to calculate the probability value and you have to calculate the permissible range. So, I have to generate the ants randomly and you have to map the ant with the path as well as the forming of the combination. So, that way you have to generate it effectively and you have to follow the optimization functions. So, pheromone adaptation path. So, you have to start the control parameter initialization, pheromone initialization, calculate. So, let me discuss this flow chart with respect to an example. Let us take the control parameters. What are the control parameters? Number of variables, number of permissible value, number of ants P, pheromone decay factor, pheromone error factor, minimum pheromone value, number of iterations. So, these are all the control parameters that one has to understand before starting the ant colony optimization algorithm. Let us take the same sphere function to understand how the ant colony optimization is working. Now, here n equal to 2. So, this is the range, x1 is in the range 1 to 4 and x2 is in the range 1 to 6. Now, what is the first step? Initialization of control parameter. The dimension is 2, there are 2 variable. So, pheromone is 1 comma 4 and 1 comma 6, number of ants 5. So, iteration 20 and error factor is 0.5. So, pheromone initialization, this is the pheromone initialization. So, tau ij. So, this is for first ant, this is for second variable x1 and x2. So, what is the calculation of probability value? Probability value is calculated like for this probability value you have to calculate like this. So, 0.25, 0.25, see 1 divided by 4 ones if you sum that. So, 0.25. So, for this and for the design of the variable 0.6, this 0.6 is calculated. This is the calculation of the probability value next to the pheromone initialization. Once the probability value is calculated, now this Pij is looking like this, right. 0.25 for all the cases, 0.1067 for all the cases. What is the next step? Calculation of the permissible range for path construction. So, this 0.25 is falls in this range and this 0.2520 is falls in this range. Like this we are calculating the permissible range for both the variables, permissible range, and based on the permissible range you have to calculate the path. So, the permissible range general notation is given like that, 0 to Pij, then the Pij is comes here, see 0 to 0.25, 0.25 is come here, then 0.25 to 0.5, see 5 comes here, 5 to 7, see 0 to 0.5, then 0.5 to 7.5, like that it is goes on, So, random generation, now random generation, see this is the random generation of ants. Now, the most important step is generation of ants are within the value 0 to 1. Now, I have to map under which path this ant will take, right. See, look at it, 0.6443, which place? See this third place, so it is taking third. What is 0.3786? This is between 0.25, so this is 2. Likewise, you have to mention. Let me take this value 0.5870, 0.5870 bar, so it is 3. 0.5870, 5870, this is 3. Oh, so here you have to mention 0.5870. In this matrix, you have to see 0.5870. It's here. It is 1, 2, 3, 4. So, this is for the first one and this is for the second. Let me take this one 0.875. 0.875 where it is 5. So, I have mentioned the 6th position, right. So, accordingly you have to form the combination C, like this kind of combination you have to find, and for each combination you have to evaluate the objective function, and based on the evaluation of the objective function you have to reach the best value. Here the best fitness value is 20, almost here you got 2, 4, you got the best fitness value. So, like that you have to select the best path. After selecting the best path, you should update the pheromone. For pheromone updation like velocity and position updation, like genetic operations like crossover and mutation operations, here also the pheromone updation is there. So, pheromone updation is carried out. So, pheromone updation values are this. After updating the pheromone by substituting in the formula like this, here your pheromones are updated like this. After the pheromone has been updated, so you have to update 2 things. One is a local pheromone updation, another one is global pheromone updation. Once the local as well as global pheromone updation has been done, so finally the process has been repeated like what is there in genetic algorithm and what is there in particle swarm optimization algorithms, and if you could observe that the pheromone updations were effective ant position updation as well as ant path updation, and if you could see that, see the initially the fitness value is 20 and over the period of time it has been, since it is a minimization over the period and at over the point of time it has been converted, there is no improvement. This is what the ant colony optimization algorithm is all about. So, this lecture we have discussed about 2 things, one is ant bee colony optimization, another one is ant colony optimization. So, both are the foraging behavior of the social behavior of the insects, and these social behavior of the insects has been very well utilized with respect to understanding of how to solve about or how to go about the search and optimization problem, particularly in many of the engineering sectors, and more or less the variables and values that you have to taken care of is very well efficient in solving the optimization problem. Thank you.